Hi everyone. Today I'm going to have a look at the inverse Laplace transform. Now you'll recall when I started the classes on Laplace transforms, I did a diagram on the board and I showed how before we started with Laplace transforms, we would be given a differential equation and get the solution directly. But with Laplace transforms, we take the differential equation, convert it into from the time domain into the S domain into a system of linear equations, and that we did using the Laplace transform. Once we've done that, we're going to learn, and this is only next week, we're going to convert or find a solution for that algebraic system of equations and then convert back into the time domain using the inverse Laplace transform. In the last few classes, we focused on the Laplace transform. Now I want to look at the inverse Laplace transform. And essentially what you're going to do there is move, if you look at the table that we worked with, we're going to move from your f of s or your transform back into your f of t. And I'm going to do this using an example. Before we do the example, please note that your inverse Laplace transform is noted like this. You would be given some function f of s, so it would be in terms of s. You would then apply the inverse to that transform, which means you get a function f of t. Okay, but you'll see what I mean as we go along with the examples. So, our first example, we are going to look at an f of s equals f of t equals 1 over s plus 3, right? Now, this notation you can choose again between f of s, or if you don't want to use the f of s, you can use that cursive L and f of t. You can use plain L as well if you want to. Just choose one and then you can apply it to all your exercises. Okay, so now we want to take your function in terms of s and you want to get something in terms of t. So if we look at our diagram and you look at the exercise that you've got, the example that you've got, you want to look at the f of s column here, right? And you want to look at your denominator first because you want to find uh, the same form as your example or your exercise. So if we look at the denominator, you see you've got s to the power 1 plus some number. So you go down and you look for s to the power 1. Right? You see there's s to the power 1, but you don't have your constant value next to the s in your denominator. So if you move further down, you'll see you've got squared, squared, squared. Here we go. There's an s value for number 7. Right? Can you see number 7? There we go. Right? So there you've got s to the power 1 minus b. So if we look at number 7, let me write it down here. Let me compare. Right? So we've got, this is number 7 over here. If you just refer to the table that you've got next to you, you've got the s value and you've got a constant next to the s, right? The only difference between these two is that on your table you have a minus sign and on your exercise you've got a plus sign. But that plus sign, all that means is you must just change the form of your function, right? So we're going to write that as 1 over s minus 3. Okay, because then you've got the same form as number 7. So you would have that denominator is going to be s minus b, right? So in this case, your b is going to be minus 3, right? So if we go back again to the table, you look at your table, s minus b, you want to go from this column back to f of t, which means you want to go from 1 over s minus b back to e to the bt. So if we look at it now, our example again, let me just fold this so you can see it easier. Right? So that's the form that we have, which means that our inverse is going to be f of t, right? You've got the e, right? Your power is going to be b times t, so you have the t, and b in this case is going to be minus 3, right? So the inverse of 1 over s plus 3 is going to be e to the minus 3t. And just be careful of your notation. You'll see on this line that is the transform, this is the inverse of your transform.